mathematicians. Our I can statement for today is I can find the circumferences of circles. Now remember, a circle is not a polygon. It's a two-dimensional shape, but it's not a polygon because it has curved edges and not straight lines. And they don't meet at endpoints. There isn't a vertex in a circle. So we're going to talk about circumference first and then build up to finding the area of circles. So some key vocabulary you should know. First of all, a circle is a shape made by drawing a curve that is always the same distance from the center. So this part of the curve is always the same distance from the center as this part of the curve, as is this part of the curve, as is this part of the curve. Okay? And the center is just this little point in the middle. The radius then is the distance from the center to any point. So our radius shows up right here. Okay? The distance from the center to any point. So I could take my radius and I could move it, and it would still be the same distance from the center to any point. This line would be the same length as this line, which would be the same length as this line, which would be the same length as this line. So think of it as like a dial that you could rotate around like on a clock. It's always the same distance from the center. Erase these. That's the radius. Then you have what's called the diameter. The diameter is the distance across the circle through the center. The distance across the circle through the center. Okay, that's the diameter. The diameter is double the radius if you think about it. Double the radius. Because we have a radius that could go from here, the center, to any side. That's half the diameter. And then it could go the other way. If you double it, you get the full diameter. So the diameter is the distance across the circle. And again, we could have the diameter go like this. We could have it go like this. We could have it go here on the circle. It doesn't matter because the circle is the same distance around from the middle point. And last, you have what's called the circumference, and that's what we're trying to figure out. The circumference is the distance around the circle. Think of it like the perimeter, the distance around. So when we do perimeter, we usually add up the sides, okay? But with a circle, we don't have sides we can add up. So we call it the circumference, the distance around the circle. Now that we have some vocabulary, let's take it to the next step. The ratio of a circle's circumference to its diameter is represented by the Greek letter pi, which we've talked about this year. Pi is a non-terminating decimal. That means it never ends. 3.14157, blah, 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 blah. It just keeps going on and on and on. So in math, we use what's called an approximation. We round it. We get close because we don't want to type in all of those numbers all the time. Some calculators have the pi symbol, and that will be more accurate because it does use the non-terminating decimal. But for our purposes, we're just going to shorten it. So when we look at pi, we're either going to use 3.14 or the fraction 22 over 7. Mathematicians have figured out that gets you to approximately pi. Okay? And that's what we want to use. Now let's talk about what that means. A ratio compares two numbers, and this is comparing the circumference around the circle to its diameter, which is this distance across. So they're saying the circumference, the areas around, is about 3.14 times bigger than this diameter. So it takes about 3.14 diameters, 3.14 of those blue lines, to equal the distance around the circle, the circumference. So 3.14 of these is the same as the distance around the circle. Okay, so how do we find the circumference of a circle? We use formulas again. There are two formulas for finding the circumference of a circle. Circumference equals pi times d the diameter. So you just take 3.14 times the diameter and you get the distance around, okay? Or if you have the radius right here, which is half the diameter, right, from the center right here, you could do 2 times pi times r, because 2 times the radius is going to give us the diameter. Mathematically, that makes sense. That reasoning works because you have two distances of radiuses, or radii, across, which equals 1 diameter. So if we take 2 times the radius times pi, it's the same as taking pi times the diameter. Okay, so let's say we have, erase this here, we have a radius of 9 centimeters, and we have a diameter of 18 centimeters. Let's start with the radius of 9. If the problem gives us the radius, we're going to use this formula. Or we double our radius and we use this formula. You could choose to do that because we know double 9 is 18 for our diameter. And that always works out. Radius is always half of what the diameter is. So let's make a formula. C equals 2 times pi times radius. Always start with your formula. Then plug in. C equals 2. We know pi we're going to use either 3.14 or 22 over 7. So let's use 3.14 times the radius of 9. Combine like terms. 2 times 3.14. So 2 times 3.14 gives us 6.28. So 6.28 times 9. Switch to parentheses. And we'll times that by 9, and we get a circumference of 56.52 centimeters. This is distance around, so we're not going to square it. We're not finding the space inside, we're finding the distance around the circle. Okay, now if we use the same formula, but we use the diameter, the 18 for the diameter, and plug in using this formula, we'll get the same answer. C equals pi times diameter. Then plug in your numbers. Remember, always write your formula first. That's important. Let's do 3.14 again, times our diameter of 18. And 3.14 times 18 should give us 55 point... Whoop! Let me try that again. 3.14 times 18 gives us 56.52, which is what we had before, centimeters. So both formulas work. Okay, let's try another example. Finding the circumference of a circle. They have given us the diameter. They've given us the diameter. We'll ignore these down here. The diameter is 49 inches. Remember, diameter is all the way across. So I'm going to use this formula instead. So C equals pi times d. Plug in our information. Pi will say 3.14. Diameter is 49. Put it into our calculadora. 3.14 times 49, and we get 153.86 inches. Again, we don't square it because this is distance around, not the space inside. How about this one? It gives us the circumference. So I have two choices. Cross that out again. We could do this formula, circumference equals 2 times pi times r, or we can make it simpler and work with this. We know the radius is double to be the diameter, so we have to double it. So I could say the diameter then equals 200 centimeters, because if I double it, go out this way, that's another 100 centimeters. Okay, so let's use that. Circumference equals, and I'm going to use the fraction this time because I don't have my calculadora. So we'll do 22 over 7 instead of 3.14 times 200. Okay, so that means 22 over 7 times 200 over 1, which gives me, let's see, 200 times 22, 0, 0, 4, 0, 0, 0, 4, 4,400 over 7. Whew, good thing we can use calculadoras, because then we'd have to reduce or divide our fraction, 4400. So 7 goes into 44, 6 times, which is 42. That gives us 2, bring down the 0, 7 goes into 20, 2 times, which is 14, 10 minus 4 is 6, bring down the 0, it goes into 60, let me think, 8 times, which is 56, 10 minus 6 gives me 4, okay, now I can do my decimal, bring a 0 down, goes into 40, not 6, 5 times, minus 35, and then we have 5, and then we bring down a 0, it goes into 57 times, 49. You get the idea, and we keep going. So the circumference is about 628.57 centimeters. And again, that should be 3 times bigger than 200. And that's about right, because 200 times 3 is 600, so that's about 3.14 times bigger. Our formula works out. All right, that's all I have for you for circumference of a circle. Remember, radius is half the diameter. Rewatch the video if you need to, fill out the Google form, and let me know if you have questions.